Hi, hello, good afternoon. Hi, hello, good afternoon, everybody. Welcome to the session. Welcome to BYJU'S Exam Prep, the most comprehensive preparation app for the all competitive examination. Can you hear me? Are you able to listen my voice? Can you tell me audio and video both are clear or not? Please do let me know your presence and try to share this session with your friends also so that they will also get benefited. I am not able to see this comment. Khan something. Good afternoon, Kalyani. How are you? So just give me a minute so that I'll do the settings and we'll start. Okay. Audio, video, both are clear? Right, clear? Then we'll move on. Right. So in the last session, we had a discussion on series DC circuits. Now in this session, we will move on. We will discuss about series AC circuits. So when the source is DC source, now the network is going to possess an opposition of only resistance parameter. If the source is AC, you will be having an opposition parameters like resistance, inductive reactance and capacitive reactance also. Okay, the frequency dependent opposition also going to be there, right? So we will discuss that. And anybody tried yesterday's homework? Anybody tried? Anybody tried yesterday's homework? Before moving on to the session, there's a small introduction about myself. My name is Naveen Gollapally. I have 7+ years of experience in teaching. Most of the times I'll be teaching networks, measurements, machines and power systems. Okay, all right. So anybody tried this one homework? I've given hint also. You take this from ground, then you'll get it. Current is there, voltage is there, voltage source is there, current is there. He's asking about R1, R2, R3, R4. Anybody tried? Come on, my dear, respond. Good afternoon, Yogananda. Let's move on. Let's see. So this current 16 amperes current will flow through R1, R2, R3 and R4 like this, no doubt. So entering polarity will be positive, leaving polarity will be negative, positive, negative, positive, negative, positive, negative like this. Okay. He's saying that this terminal potential is 48. So please always remember this terminal potential is 48 means from the ground. From the ground till here, if you go ahead, you are going to get 48 volts. Okay. So from 100, there is something is going to be dropped. From 100, something is dropped and remaining potential is 48. Okay. Now similarly, this terminal potential is 12 volts means from the ground till this terminal, it is 12 volts. It is negative means from the ground, if you move to this terminal, you are going to get negative 20 volts. Okay. So be careful with respect to all this. Now you can calculate easily. So let me show you how it is going to be. I'm redrawing by taking ground as common. Now this side I have R3, R2 and here I have R1 and here I have 100 volts voltage source and 100 volts voltage source and R4 like this. If you assume this as a terminal A, ground point as G, let me take up as G ground point and this as B. So the ground point is going to be G and this terminal is going to be B. The finishing terminal of R4 or otherwise moving, this one. So this is B. So B terminal is with negative polarity. Why B terminal is with negative polarity? Because the current is flowing in this direction. So obviously positive, negative, positive, negative, positive, negative, positive, negative. So from the ground, it will be having a potential of 20 volts. From the ground, it will be having a potential of 20 volts. Similarly, R3 how much? From the ground, it is having a potential of how much? He has given 12 volts. Okay. You know current in each and every element. How much is that current? Current is 16 milli. So current into resistance is equals to voltage. Now we know the voltage across R3 already. We know the voltage across R3 already. That is 12. So 12 divided by current. So the R3 will be resistance. Voltage divided by current. How much you are going to get? 16 milli. So if it goes up kilo. So 3 fours are 4 threes, 4 fours. So 3 by 4. Maybe 0.75 kilo ohms. R3 is 0.75. Similarly, you can calculate here also what is the resistance value R4. R4 is equals to voltage divided by resistance. 20 divided by, sorry, voltage divided by current. Current is how much? 16 milli. If it goes up kilo. So 4 fives, 4 fours. It will be 5 by 4. So 5 by 4, it will be around 1.25. 1.25 kilo ohms R4. Now what is R2? What is R2? R2, the current flowing through this one is 16 milliamperes. What is the voltage across that one? Be careful. What is the voltage across that one? Be careful. Can you tell me what is the voltage across this one? Very good, Kalyari, superb. Can you tell me what is the voltage across that one? I am hiding, so please see. I am drawing here R1, and of course this is connected to 100. He is saying this point as 48, na? This point as 48. So 48 means how much current is flowing here? 16 milli. We know potential difference. Potential difference divided by resistance. That will be the, of course, potential difference by current. That will be, you will be getting resistance. R1 is equals to 100 minus 48. If you have any doubt, you apply KVL. Plus 100 minus I into R1 and minus 48. So this is positive from the ground and this is negative. You can write. Okay. If you have any doubt, you can write KVL. You write KVL plus 100 minus 16 milli into R1 minus 48 is equal to 0. So R1 is equals to 100 minus 48. It will be 52. 52 divided by 16 milli. So 52 divided by 16 kilo ohms. This is R1. Similarly R2 also. Similarly R2 also. R2 is how much here? R2 is, I am applying here itself. So plus 48 minus I2 into I into R2 minus 12 is equal to 0. Plus 48 minus 16 milli into R2 minus 12 is equal to 0. That is how you need to apply KVL. So R2 is equals to 48 minus 12. You are going to get as 36. 36 divided by 16 kilo. Around 1.2, 16 to the 34, yeah, 32. Around 2 point something you are going to get. 2.25 or 2.35 something. So this is how you can solve. Everybody solved? Is this clear for everybody? Is this clear for everybody? Respond, my dear. So that we can move on to the next question. You have any doubt, please ask me. I have given one more question. This is one more question homework. I have given. Anybody tried? How much is the answer? You know, current, if the current direction is not given, be careful. If the current direction is not given, there is chance of getting two possible answers. Let's see. You assume the current direction in this direction, in the clockwise. If you assume in the clockwise direction, he said that this power is 8 milliwatts. So the current flowing through this is going to be 2 milliamperes. So power is 8 milliwatts. So what is the resistance? I square into R is equals to P. So R is equals to P is 8 milli. I square is 2 milli square. That will be, it will be around 4 micro. So it will be, if this micro goes up mega, so I think you are going to get R is equal to 2 kilo ohms. Whether the current direction is anti-clockwise or clockwise, our resistance is going to be 2 kilo ohms. Now I have got total resistance. I have to calculate E. So as I am saying that current is circulating in the clockwise direction. Now I can take up. You write KVL. I am moving from here to here. So plus E. Minus E, leaving polarity now. Minus E, all polarities are going to be like this. Minus E, current into resistance. So that is minus 2 milli into 5 kilo. Next, what is the leaving polarity? Plus 20 is equal to 0. So E is equals to, this will be millikilo gets cancelled, 5 2s are 10, minus 10 plus 20, so it will be plus 10. E is equals to 10 volts. If you assume the current direction in the reverse, it will be different answer. So if current direction is not given, you are going to get two answers. Okay, E is equal to 10 volt. So if you take up current direction in a different manner, like in anti-clockwise, let me hide and let me show you. This is positive, negative, so here it is E. And I'm simply writing two resistors, I'm replacing with single resistor. And here this is the plus minus 20. Okay, I'm assuming current direction in the anti-clockwise direction. I'm assuming current in the anti-clockwise direction. So here it will be positive and negative. Okay, so chalo, take up all leaving polarities take up now. So leaving polarities I'm considering minus 20 minus current, how much current? 2 milliampere. 2 milliampere because he has given. Okay, so 2 milli into, I'm considering leaving polarity. Okay, leaving polarity here. 2 milli into 5 kilo and plus E is equal to 0. Millikilo gets cancelled, 5 2s are 10, minus 10, minus 20, so it will be 30. So E is equals to 30 volts you are going to get. So there are two possibilities if the current direction is not given. There are two possibilities if the current direction is not given. So when you keep E is equals to 10, the current will flow in clockwise direction. When you keep E is equal to 30, the current will flow in anti-clockwise direction. Obviously, if E is greater than 20 volts, current will flow from E to V, na? E to 20 volts. If E is less than 20 volts, current will flow from E to V. Okay. So this point you need to understand. Depends upon the potential difference, the current direction also going to be changes. Is it clear for everyone? Is it clear for everyone? Respond, my dear. So that we can move ahead. If anybody has doubts, please let me know. Okay. Now see here. So we are going now in this session, like we are going to take up series AC circuits. Series AC circuits. So in this session, what we are going to discuss is we are going to find out the current, voltage and power levels or power values of each and every element. Okay, we are trying to calculate current value, voltage value across each and every element. What? By using KVL, by using voltage division rule. Okay, so we are going to find out the KVL. We are going to take the help of KVL on the series configuration or series connection, and we are going to take up the voltage division rule also to find out the voltage across each and every network. So these are the points I am going to discuss in this session. Of course, even we are going to calculate the total impedance also of series network, and the impedance diagrams also I am going to draw. Okay, so in this session, in the upcoming coming maybe 40 minutes or 50-minute session, I am going to take up these things. Okay, fine. Ready, guys? Shall we start now today's session? Right. Moving here, I've got simple questions, so please try to. When it comes to series AC circuits, series DC circuits, or parallel AC circuits, parallel DC circuit, it will be simple. When you combine them, then you will get it takes some time to solve the networks. Okay, so I have got in this session, I have got very simple questions. So when I go with the series parallel connections, then I'll try to take up some good questions. Okay, that means definitely that will be time taking question. That is what I wanted to say. Okay, so first learn the basics here. Using complex algebra means, you know, J notation like x plus iy. Find the voltage, V for the circuit in the figure, for the circuit shown in the figure. Here is the circuit. Sketch the waveform of V and I. Where is V? V is the voltage across resistance. Okay. So remember here, if I is given as 4 sine omega t plus 30, you assume sine as reference. If I is given as 4 sine omega t plus 30, this is a time domain. You can represent this waveform as like this. You take up 0. The current is not starting from 0. Current is ahead, much ahead from the 0. How much ahead? 30 degrees ahead. Plus 30 degrees means 30 degrees ahead. So this magnitude is going to be 4 sine like this. So this maximum magnitude is 4. So that instantaneous time is represented in terms of waveform. You can represent even in terms of phasor domain also. How can you represent in phasor domain? I is equals to 4 at an angle 30. That means what? If you take up a reference phase, this is a real axis and this is an imaginary axis. So on the real axis, this is 0 degrees and this is 90 degrees, right? Okay. Now I of t, it is not actually at 0 degrees, it is 30 degrees. So positive from the reference, you have to draw 30 degrees. So it will be like this. So this is my I. From the reference, it will be 30 degrees. Okay. So this is phasor representation and this is time domain representation or waveform representation. There is time domain and phasor domain. Okay, he's asking you to sketch the voltage waveform and current waveform. We'll sketch them. First of all, we have to calculate voltage. Can you tell me what is the voltage here? Voltage is going to be current into resistance. That is 4 at an angle 30 into resistance of 2 at an angle 0. There is no phase angle displacement between voltage and current because of resistance. So I'll be getting 8 at an angle 30. So I can write it as 8 sine omega t plus 30. 8 sine omega t plus 30. So if you take up the magnitude, this magnitude of the current as around 4 amperes. This magnitude, otherwise this magnitude, or not cos component. This magnitude as 4. Now voltage magnitude is 8. This is the voltage magnitude. The voltage and currents are in phase. So if you write a voltage waveform, it will be like this. I'll show you the voltage waveform also. Did you understand so far? Current, instantaneous current I have represented in time domain manner. Instantaneous current I have represented in phasor domain also. This one, 4 at an angle theta. Okay. I have calculated voltage drop. Then I have represented even voltage also on the phasor. Okay. If you want me to show the voltage and current together waveforms, it will be like this. See. If you have any doubt, please ask me. We are going to take up the session very slowly because you should not feel difficult when you are solving RLC series parallel circuits. So that is my intention. I am taking small topics so that when you solve together, then it will be very easy. Do you have any doubts in the previous slide, everybody? Anybody? Tell me, my dear. You see, current is started from 30 degrees ahead and its maximum value is 4 amperes like this. So 180 degrees it is 0 and 270 and 360. The voltage waveform also in phase with the current. The moment when the current becomes 0, voltage also 0. The moment when current is maximum, maybe at 5, this is a little bit slided. Okay, you can take up this point. So at this point, voltage is also maximum. The moment when current is 0, voltage is also 0. The moment when current is maximum, voltage is also maximum. Voltage maximum, current maximum are happening at same point. Voltage 0, of course, current 0, voltage 0 are happening at same point or same time interval. So I can say that voltage and current are in phase, or voltage and current does not have any phase displacement, does not have any phase difference. So is this clear, my dear? So this is how you can represent the waveforms. Let us take up in another way. I have a resistor like this. I have a resistor like this. Earlier I have given current, now I have given voltage. You see, this voltage is having some angle. This voltage is having some angle, that is 10 degrees. So that means what? V, I can write V as 15 at an angle 10. So if you take up reference, so from the reference the voltage is the voltage is at 10 degrees. So this is imaginary, and let me show you the voltage. So it is at 10 degrees and this voltage magnitude is of 15 volts. Maximum magnitude only. I am not representing RMS. If you want to represent RMS, you can go ahead with it divided by root 2. No issues. This is maximum value only. Now I wanted to calculate current. Can you tell me what is a current? Current is equal to voltage divided by resistance or not? So current is equals to voltage divided by resistance. So voltage is of 15 at an angle 10. Resistance is of 3 at an angle 0. So you will be getting 5 at an angle 10. I can write this as 5 sine omega t plus 10 degrees. So where will be our current phasor? Now current phasor will be in phase with the voltage, and this magnitude is of just 5 amperes. Voltage and current are in phase. Yes, you have to, from the reference it should be 10 degrees again. From the reference, current phasor also should be 10 degrees. Okay. So this is how the phasor domain exists. How will be the waveforms? The waveform starts like this. The waveform will be like this. If the voltage waveform starts from 10 degrees, and this is the voltage waveform, which is a maximum magnitude of 15. Now the current waveform will be like this. Current waveform also should start at 10 degrees. Okay, and should reach maximum at the same time, should reach 0 at the same time, should reach negative maximum at the same time. But with what magnitude? Maximum magnitude is 5 amperes only. So let me take up 5 amperes. Let me take up 5 amperes. So this magnitude is 5 only. Okay, so this is how you are going to get. Current maximum, voltage maximum are going to happen at the same time. Current 0, voltage 0, it is going to happen at the same time. So resistor is not going to create any displacement between phase difference between voltage and current. Voltage and currents are in phase. Voltage and currents are in phase. So this is how you can sketch the waveform, and these are the phasors. Okay, clear for everyone? Clear for everyone? Yogananda, I just started in the yesterday session. Now look into the inductor. Look into the inductor. He is asking find current I for the circuit shown in the figure, and he is asking sketch the voltage and current waveforms. Okay. Remember whenever you are going to calculate current and voltages, please take the use of J notations. Okay. Inductive reactance. For inductance L, it will be J omega L, or otherwise J XL. For capacitor, here this inductance units are henries, capacitance units are farads, but I want opposition for the current flow we need to represent. So this opposition is 1 by J omega C ohms, or otherwise minus J XC ohms. So please replace the inductor with their oppositions. Please replace the capacitance with their oppositions. Okay. So here he has given XL is equal to 3 ohms. So you do not forget J notation. So it is actually JXL is equals to J3 ohms. So I have opposition, I have voltage. Now can't you calculate current? Use Ohm's law. I is equals to voltage divided by XL. So what is voltage? Voltage is of, you can write voltage is of 24 at an angle 0. So 24 at an angle 0 divided by JXL, that is J3 at an angle 90 degrees. Now I can write I is equals to 8 at an angle minus 90 degrees. So if you see the phasor, it will be like this. Real axis and imaginary axis. Where should I draw? The voltage waveform? The voltage waveform, here it is, angle is 0. So I should draw voltage here. This is my voltage. It doesn't have any phase displacement. So I am taking on 0 degrees. Okay. I'm taking on 0 degrees. So this is the voltage across the inductor. There's a voltage across the inductor. Now where will be the current? Current is of minus 90 degrees. Current is of minus 90 degrees. So here is your current magnitude. Of course, voltage magnitude is larger than current magnitude. Let me indicate large value. So current magnitude is this much. This is the current with a phase angle of 90 degrees. If you move from voltage to current in the clockwise direction, it will be negative, lagging, you can say. Anti-clockwise direction, that will be positive or otherwise leading. So remember these points. So this is how I can represent. How will be the voltage and current waveforms? Please see. Is it clear so far? Voltage and current waveforms. See, I am giving individual components. I am giving resistor, inductor, capacitor, so that it will not be confused when you combine them. For series, for parallel, you will not get confused. But when you mix them, you will get confused. So that is the reason why I am taking individually, then I will mix. Okay. So far, is it clear how we have drawn voltage phasor, how we have drawn current phasor? Now see the voltage and current phasors. Yoganam, right. See here. The voltage waveform is at from 0 degrees. So voltage waveform is like this: 24, 0, maximum negative 24 and 0 and so on. But current waveform is started after 90 degrees. Current is lagging. So voltage started here, but current is going to start after 90 degrees. Current is going to start after 90 degrees like this. So this is a delay. This delay is because of what? Inductor will not allow the sudden changes in current. The current is delayed by the voltage because inductor will not allow the sudden changes in current. Inductor will not allow or won't allow the change in currents or sudden change in currents. Why? Definitely, whenever the source is connected, there will be an EMF in the inductor, and that EMF tries to oppose the source voltage so as to not pump the current into the inductor. Okay, that is the reason why inductor current is delayed. Is this clear, my dear? Is this clear for everybody? And Kalyani is asking if we represent I with plus 270. Is it right or wrong? Yes, it is absolutely right. No doubt. If you are moving in clockwise direction, I am saying it as lagging. If you move in anti-clockwise direction, plus 90, plus 180 and plus 270. So I is 270 degrees leading with respect to voltage. In that way also fine. So this I 8 at an angle 90. Current lags the voltage by 90 degrees or otherwise. Current leads the voltage by 270 degrees, also fine. Is also fine. No, nothing wrong. You can say like that also. Now look at this one. Ananya is asking one doubt. Please see Ananya in this question. Please try to see, try to understand in this question. I have taken capacitor. So in the capacitor, please try to understand. Okay. In general, okay. Phasor I am saying, if you are moving in anti-clockwise direction from this phasor to this phasor, okay, anti-clockwise direction, it is taken as positive angle, okay. So this is, you can also call it as, you are here, okay. It can be current quantity, it can be voltage quantity, doesn't matter. The person 1 is here and the person 1 is here. If you are moving in anti-clockwise direction, I can say that this person is leading with respect to this person. Person 1 is lagging with respect to person 2, or otherwise person 2 is leading with respect to person 1, because you are moving in the same direction, you are moving in anti-clockwise direction. So if you move in anti-clockwise direction, then you can reach this person. That means what? This person 2 is much ahead compared to you, person 1. Okay, alright. If some person is here, one more person is here, right? Now what we are defining, if you are moving in anti-clockwise direction, we can say person 3 has to move in anti-clockwise direction to reach person 1. So person 1 is much ahead compared to person 3. So I can say person 1 is leading with respect to person 3, or otherwise person 3 is lagging with respect to person 1. Simple. Okay, instead of taking anti-clockwise leading, if you move in clockwise, let me show you. From person 1 to person 3, if you move in clockwise, then I can say here person 3 is lagging with respect to person 1. Did you understand? Take one reference and you see whether if he is ahead, you can call it as leading. If he is behind, you can call it as lagging. So that is how you can define. So anti-clockwise is defined as leading and clockwise is defined as lagging. That's it. Is it clear now, Ananya? No, you cannot take anti-clockwise or clockwise. Simply see the voltage and current. See the angle between voltage and current. Let's see. I'll show you here. Find the current I for the circuit shown in the figure. Sketch V and I. So I have voltage. So voltage is equals to 15 at an angle 0. Okay. So I am taking this sign, voltage quantity, as reference. Now there is a current flow. So you have to replace XE with minus JXE. So this will be minus J2 ohms. What will be current? Current is equals to voltage divided by minus JXE. So you'll be getting 15 at an angle 0 divided by minus J2, that is 2 at an angle minus 90. So I can say that it will be 7.5 at an angle plus 90. So how do we draw? Please see. I am taking a reference phase 0. I am taking it as positive imaginary, so plus 90, negative imaginary minus 90. Okay, negative imaginary minus 90, like this. How? If you move in clockwise, this is, you are saying it as negative. If you move in anti-clockwise, you are taking it as positive. Okay, fine. See, I am taking voltage as a reference. So this has a magnitude of 15. This has a magnitude of 15. And the phase angle is 0. So I have taken here voltage. Now where should I draw the current? The current is of 7.5 magnitude with a phase angle of 90 degrees. With respect to what? With respect to voltage. This voltage is of 15 volts at an angle 0 I have drawn. Now with respect to voltage only I have calculated. So the current is 7.5 magnitude and the current angle is 90 degrees. How much? Plus 90. So where is plus 90? Here. So here I have to write. Now this is the capacitor current. Now the angle between voltage and current. Now see here, you can define. If you are moving from voltage to current, you can define current as leading with respect to voltage. If you are moving in anti-clockwise direction, you can define IC leads with VC or V by 90 degrees. You can write like this. R. If you are moving from current to voltage, now voltage is leading, na? Voltage is leading with respect to IC. V leads with IC by 90 degrees. Why? If you take current as reference, oh sorry, I think I missed this point. Oh, I'm sorry. Yeah, if you take from the current, if you take up and you can say like that, but be careful. But voltage is my reference now. Voltage is reference. So I am moving in clockwise direction. If I move in clockwise direction from the current, so here is the voltage. If the current is a reference, voltage leads or VC leads. Yeah, that is what I have written. VC leads the current. When you take current as reference, let me hide and show you. If I take up current as reference, here is the, I have written in reverse, I think so. Yeah, voltage should be here. So from the current, if you move here, I can write V lags the current. V lags the IC. So be careful. If you go ahead with the clockwise, it will be lagging. You can write. If you are moving in anti-clockwise, it is going to be leading. Take up leading. Is it clear or still? I am moving in clockwise direction. Is it clear or anybody still have doubt? Raya, it can be both the branches, ECE and EEE, both the branches. Okay. So it all depends upon, Ananya, it all depends upon. So you have whether you move in anti-clockwise direction or clockwise direction. So be careful with that one. Clockwise, take it as lagging. Okay. Anti-clockwise, take it as leading. So reference is very important. So from IC, if you are moving, from voltage, if you are moving anti-clockwise, that will be leading, you can say. Voltage waveforms I did not show you. I'll show you the voltage waveforms. Voltage waveform is 0, started at 0. So let me show you voltage waveform. This is my 15 is the maximum voltage. So I am taking 15 is the maximum voltage. Positive maximum, negative maximum. This is voltage. Now where will be the current? Current should lead with respect to voltage by 90 degrees. So should lead with respect to voltage by 90 degrees means when voltage is becoming maximum, current should become 0. Okay, current is here with a magnitude of 7.5. So let me take up here like this. So this is 90 degrees. When the voltage is maximum, current is 0. When the voltage is 0, current is going to become maximum. When the voltage is negative maximum, current is going to become 0. Like this, it is going to happen. Okay. So what does it mean? Current flowing through capacitor leads with respect to voltage. What does it mean? You imagine like this. Imagine like this. Everybody, please concentrate. When you take a capacitor and connect in the socket, when you connect in the socket, what is going to happen when you connect in the socket? The moment when you switch on, you can see there is so much of inrush of electrons, and so you can see spark. You can see so much of sparks. That means what? There are huge number of electrons entering into the capacitor so as to accumulate on the plates. So the voltage is not at all formed, to say exactly. The moment when you connect the capacitor to the source, the voltage is not at all formed. Suddenly what is happening the moment when you close the switch? there is a huge amount of current flow, huge amount of current flow. So that current flow is creating the potential. First current is entering, that means what, charge carriers are starts accumulating, and then it leads to voltage formation. So current first, voltage next. So there is a delay of 90 degrees. So that is what we say, that capacitor will oppose the sudden changes in voltage existence or voltage development. Capacitor will oppose the sudden changes in voltage development. It is not charging to complete supply voltage suddenly. It is taking some time. So it is accepting current, huge amount of current, and then it is building the voltage. So current first, voltage next. Quite opposite to inductor. Is it clear? Yeah, Ananyara, you can say like that. Active power is going to be 0. So inductor does not consume, does not dissipate the power. What actually it means is P is equal to 0 means inductor is not going to, pure inductor is not going to dissipate the power. You can say according to formula also, cos 90 0, so active power is 0. Is it clear for everyone? Capacitor current and voltage form waveforms. Respond, my dear. So if you quickly respond, then we can move on. Right. Look into this one. You try here. Find the current I for the elements in the figure using complex algebra. Sketch the waveform V and I. I think you can do it, right? Just now, so far we did only. So this is, but he has given L value as 2 millihenries instead of giving in ohms. So we know the frequency omega. So V I can write it as 6 at an angle 10. What is JXL? JXL will be, that is J omega L, that is J into omega is 500, inductance is 2 millihenries. So 5 2s are 10, so 1000 into 1 milli, that comes out as J1. So 1 at an angle 90 degrees. So voltage divided by current, you will get the, voltage divided by inductive reactance, you will get the current. I is equals to V by JXL. 6 at an angle 10. Here sine is a reference, okay. 500 omega t is a frequency. According to this frequency, you have to change the inductive reactance. Divided by J. JXL is of 1 at an angle 90. So you are going to get this one as 6 at an angle minus 80 degrees. 6 at an angle minus 80 degrees. If you draw the phasor, it will be like this. Please see, everybody. I am taking real and imaginary. Voltage magnitude is of 6 at an angle 10. So from the real axis, the voltage will be at this point. 6 at an angle 10 degrees. So this magnitude is 6 volts. Now what is the current magnitude I have got? Current magnitude also I have got it as 6 amperes, but it is minus 80 degrees. Minus 80 degrees. That means what? From the reference, it is going to be minus 80 degrees. What is the magnitude? 6. So from the reference, minus 80 degrees means this is minus 90. So minus 80 degrees will come here. So this is my current magnitude of 6 amperes. From the reference, it is minus 80. You see, the angle between voltage and current, should be 90 degrees because it is an inductor. As it is an inductor, the current should lag the voltage by 90 degrees. You see, the current should lag the voltage by 90 degrees. Current is here. If you move from voltage to current in the clockwise direction, current is absolutely I'm sorry. So current is lagging with respect to voltage by 90 degrees. Is 90 degrees. Current I lags V by 90 degrees. Or otherwise, if you move in anti-clockwise direction, I can write V leads I V leads I by 90 degrees if you move anti-clockwise direction from the current. Anything is okay. Current lags the voltage by 90 degrees or voltage leads the current by 90 degrees. Anything is okay. Is it clear for everyone? Respond, my dear. Similarly, you can do it for capacitor also. If you have any doubts, please let me know. If you have any doubts, please let me know. Can you do it for capacitor? Can you do it for capacitor? So here he has given 5 kilohertz, 5000 hertz. He has not given omega. What is omega? Omega is equals to 2 pi f. So omega will be 2 into pi into 5000. 5000. So it will be 5000 into 2, 10,000. So it will be 10,000 pi. Omega is 10,000 pi radians per second. So according to that, you calculate now jxc minus jxc. Okay, 1 by j omega c is equal to 1 by j. This will be 10,000 actually. It is not just 1000. 10,000 or 10 to the power of 3. Anything is okay. 10 into 10 to the power of 3. Into capacitance of 2 micro. 2 into 10 to the power of minus 6. So calculate, you will get it as minus jxc. So voltage is there. Voltage you can take up 120 at an angle 0. You will get the current. Current is equal to voltage divided by minus jxc. Be careful. Current is equals to voltage divided by minus jxc. If you forget minus j, gone case. Will you do it for capacitor? Shall I move to the next question? Very good. Superb. Kalyani. Right. Now look into this one. Draw the impedance diagram for the circuit in the figure and find the total impedance. I have R, I have XL, that is 8 ohms. So please remember, in some examination they'll give you JXL, sometimes they'll give you only XL. So if they forget, you should not forget. Okay, it is JXL, is J8 ohms. Now what is the total impedance? Same as like resistance addition. You just assume this as R1, you just assume this as R2. What is the total resistance in series connection? R1 plus R2. So similarly, here R1 is nothing but 4 ohms. R2 is nothing but J8 ohms. That's it. Ohmic values only. J8 ohms. So 4 plus J8, this is the total impedance. 4 plus J8 is the total impedance. How do we draw the impedance diagram C? How do we draw the impedance diagram C? This is a real term and this is an imaginary term, and here is negative imaginary term and of course negative real term. So I have got 4 on the real term. So that is real axis. So this is my 4. There is my resistance of 4. And reactance, the inductive reactance is of 8. So that is J8. So it is might be I am taking this much. This is of J8 ohms. Now the summation of these two, is a resultant value that is called impedance. That is called impedance. So you can get the magnitude also if you want. So the magnitude of the impedance is going to be 4 square plus 8 square, 16 plus 64. It will be 64 plus 16. It will be 16 plus 64, na? Yeah, 16 plus 64. How much? 16 plus 64? 80. So 64 plus 16, yeah, 80. Root of 80. You are going to get around maybe 9 approximately, because 81 is going to be 80, root 81 is going to be 9, so I am taking approximately 9. Maybe 8.9 or like that you are going to get approximately. What is the angle? Tan inverse of imaginary by real. So tan inverse of 2. Tan inverse of 2. So you are going to get it as around 63.43. So I can write Z as Magnitude of around 8.9 at an angle 63.43. So from the real axis, you are going to have 63.43 degrees. So this is how you have to represent. Okay, calculation is so fine. If they very rare, they'll not ask you the phasor diagrams and all those things. But it will be, it will be useful whenever you are calculating the problems. So you'll not get confused. Okay, be careful. So remember the one point here. If the network consists of resistance and inductive reactance, the angle is positive. Impedance angle is positive. If the network consists resistance and inductance, the impedance angle is positive. If the network consists resistance and capacitance, the impedance angle will be negative because you will get minus jxc. Tan inverse of minus imaginary term divided by real term, you will get tan inverse of negative as a negative angle. Okay, so the impedance angle for the inductive circuit will be positive. The impedance angle for the capacitive circuit will be negative. Okay, so remember this point. Is it clear for everyone? Very good, Yogananda, Govindraj. Yeah, it is a lagging circuit, no doubt. Okay. Now, when you take up this impedance, with respect to voltage, now current will be I is equals to some voltage divided by impedance. What is this impedance angle? I have got positive. So, if this angle goes up, then it will be negative. V by Z at an angle negative. That is the reason why we say that current lags the voltage by negative. Current lags the voltage by some angle. Minus theta is nothing but lagging only. Current lags by how much angle? Theta with respect to voltage. So we call this as lagging circuit. Now look at this one. I have taken three components now. So it is like simply do not take up, then don't simply just neglect about this inductive reactance, capacitive reactance, all those. Simply you just assume it as R1, R2, R3. Then the total resistance is going to be simply R1 plus R2 plus R3. I have to take the oppositions. So here the opposition is 6 ohms. Next, the opposition here it is not simply 10, it is J10 ohms. So simply write J10 ohms. J10 ohms. Then next, here it is minus J12 ohms. Okay, do not forget minus J. So minus J12 ohms. So you are going to get the resultant as plus J10 minus J12. So it will be minus J2. This is my impedance, the total impedance. If you take up the magnitude, it will be 6 square plus 2 square, 36 plus 4, 40, root 40 will be, 42 will be 41, I think, root 40, na? So around 6 point something, 6.35, 6.32 I am getting. With a magnitude theta as tan inverse of minus 2 by 6 or minus 1 by 3, tan inverse of minus 1 by 3. I am getting around minus 18.3. Okay, I am getting around minus 18.3. You see, negative angle. That means what? Capacitive reactance is dominating the inductive reactance. The capacitive reactance is more dominant than the inductive reactance. So I have got negative angle. Impedance angle as negative. For capacitive circuits, impedance angle will be negative. Even though we have an inductive nature, the capacitive reactance is much dominant than the inductive reactance. So I have got the impedance angle as negative. Okay. If you want me to represent in the phasor, let me show you the phasor. Real term and imaginary term. Where is a real term? 6. Imaginary term is minus 12. Let me indicate this inductive reactance and capacitive reactance also. So real term is 6. R is equal to 6. Inductive reactance, that is plus J10. So it is this much. This is JXL. 10 ohms. Anyhow, J is fine. This 90 degrees we are representing already. So no need to write again J. 10 ohms minus J12. So it will be much greater than inductive reactance. So this is minus J10. sorry, minus J12, so minus 12 ohms. So here they are inductive reactance and capacitive reactance are opposite to each other. Opposite to each other. So you can compensate. If you can compensate, the rest out, how much you are getting? 2 minus J2. So it will be minus J2 this much. Now the resultant of these two will be the angle. The resultant of these two will be the angle R minus J2. This is the resultant Z. You see, now from the real axis it should be an angle of 18.43. From the real axis it should be an angle of 18.43. From the real axis, the Z to the Z, it will be an angle of, this is a theta, minus, lagging now. So from real axis you are moving in clockwise direction. As you are moving in clockwise direction, I can call it as negative. Is it clear? So when you are trying to calculate current is equal to voltage divided by Z at an angle minus theta. If you write current is equal to V by Z, if this theta goes up, then it will be positive. So I can say that current is going to lead with respect to some angle, with respect to voltage. Current leads the voltage by some angle. Is it clear for everybody? Is it clear for everyone? Please tell me. Ananya, that is what? If you wanted to say how it is going to be leading or lagging, XC greater than XL. So more capacitive nature. So absolutely it is going to be leading circuit. So you can see the phase angle also. Phase angle you are getting negative. So definitely impedance phase angle is negative, not the angle between voltage and current. Okay. All right. So clear for everybody? Then we'll move on to the next session. Next question. What is the time? 127. Chalo. I have got here the resistance and capacitive reactance. So he is asking to calculate voltage division rule. Find the voltage across each element. I am again saying, do not panic about the J notations. Simply write this one and make this as R1. Assume this as R2. How did you write the voltage division rule for the resistors? In the same manner here also. The voltage across R1 is equals to source voltage into that resistance divided by total resistance. That's it. Now here we do not have all resistors. We have capacitive reactance. We have inductive reactance. So replace them simply. Instead of R2, I have minus JXE. So write minus JXE as usual. Ohmic value minus JXE. So E is of 100 at an angle 0. Remember, if they have represented like this is an RMS value. I said, especially in gate. In some textbooks, they'll take it as maximum value. In some textbooks, they'll take it as RMS value. But whenever it comes to gate, this is RMS value. Until unless they give you it as 100 sine omega t at an angle something. If the voltage is given in terms of instantaneous value, the 100 is going to be maximum. But if it is given simply R at an angle theta format, it is RMS value. Into R1 is of 3 divided by R1 3 minus J4. So I can write now 100 into 3 300, 300 at an angle 0, 3 square plus 4 square, 9 plus 16 25, root of 25 will be 5, root of 25 will be 5, and 5 at an angle, this tan inverse of 4 by 3. Can you tell me what is tan inverse of minus 4 by 3? Do not forget minus. If you forget minus, gone case. Minus 53.13 degrees. So voltage across a resistance. Now let me write here. Voltage across a resistance VR1 is equal to, you are going to get 5, 6 or 30 I think. So 60 at an angle 53.13. 53.13. So voltage across a resistance is leading with respect to reference by an angle of 53.13. Okay, we'll see here. All right. Is this minus 53.13? Everybody has got this one so far? Right, done. Now, moving on to the voltage across a capacitor. Similarly, voltage across a capacitor also you can calculate. Voltage across a capacitor will be source voltage. Source voltage is 100 at an angle 0 into that resistance. Simply you can write it as R2 divided by R1 plus R2. R2 is what? Minus JXE divided by R1 plus R2. What is that? R is of 3 minus J4. So let me write directly minus J4. Now here 100 into 4 it will be, I can write this minus J4 as 4 at an angle minus 90. 100 at an angle 0, 4 at an angle minus 90 divided by 3 square plus 4 square, we have got it as 5. 5 at an angle minus 53.13. Just now we have seen. Now I can write 100 into 4 is 400. 400 at an angle minus 90. If this plus minus 53.13, if it goes up, plus 53. Plus 53.13 divided by 5. So 5 8s are 40. You are going to get 80 at an angle minus 40 minus 37 point 36 point something, because it is 90 minus 53.13 now. 36.86. So this is how you are going to get. So if you take up the source voltage, it will be like this. Or otherwise, you see, I'll show you. Voltage across resistance. Voltage across resistance. If you take up series circuit, let me show you here. Current I am taking as reference. So voltage will be in phase. Voltage across capacitance will be it like this. It will be like this. Now this is the source voltage, total source voltage, V. Source current, source voltage. This is how it looks like. If I take up current as reference, source current as reference, okay, like this. Okay, see here. I'm repeating everybody. I'm repeating. Or let me take up in the next slide, or let me add up a slide so that I can show you. All right. So that is a series RC circuit. If you take up current as reference, current flowing through, current delivered by supply, current flowing through R, current flowing through capacitor is same. I am taking this as reference. Okay. Now, how will be the voltage across resistance? Voltage across resistance will be in phase. How will be the voltage across capacitance? Voltage across capacitance will be lagging with respect to voltage, because capacitor current should lead with respect to voltage. So this is how it looks like. Now the resultant voltage, this is going to be the supply voltage. Alright, so supply current is leading with respect to supply voltage. So it's a capacitive circuit. It's a leading circuit. Okay, from the voltage, if you move in anti-clockwise, then you can say that supply current is leading with respect to supply voltage. But we did not, I'm not going to take up supply current as a reference. I'm going to take up supply voltage as a reference. So supply voltage, if I take up reference, that is what E. From E, voltage across the resistance is leading or not? VR is leading or not? Definitely. From VS, voltage across resistance is leading. How much it is leading? How much it is leading? 53.13. Voltage across the resistance is leading with respect to supply source voltage. This is the source voltage. Voltage across the resistance is leading with respect to source voltage by 53.13. So I have to go 53.13. So this is my voltage across the resistance. How much is this? 53.13. Now what is other thing? voltage across the capacitance with respect to source voltage. Voltage across the capacitance with respect to source voltage. How much it is? Plus 36.86, plus 36.87, plus 36.87, plus 36.87. Okay. See here. If you have any doubt, you can draw this VC. You can draw this VC parallel to here. This is also VC. Both are parallel, na? You see, from VC, if you move in anti-clockwise direction, VS is leading. From VC, VS is leading. Okay. Source voltage is leading with respect to VC. So how much we have got here? Okay, capacitor voltage is leading. We have got this is, I forget this one, minus. This is, I saw, sorry, minus 36, because minus 90 plus 53.13, na? Minus 36.86. So voltage across the capacitance, let me hide. Voltage across the capacitance is lagging by minus 36.87 with respect to source voltage. You see, voltage across the capacitance is definitely, if you see from source, clockwise direction, VC is lagging. How much angle? 36 point. How much angle? 36.87. Is it clear for everyone? So from source voltage, if you move in anti-clockwise direction, 36.87 something. Yeah, 36.87. So this is VC. You add up these two, 53.13, 36.87. You add up these three. 50 plus 30, it will be 80. 3 plus 6, it will be 89. So 90 approximately. You see the angle between resistance and voltage. Voltage across resistance and voltage across capacitance. You see the angle is 90 degrees. You take up anything as reference, so be careful with that. With that reference, you have to draw. Is it clear for everyone? Drawing the phasors, if you feel it as difficult, please divide them as a part wise, like resistor voltage, capacitor voltage. Take any one quantity as reference. Either you take current as reference or you take voltage as reference. According to that, you draw. Ananya Rai, what is your doubt? It is actually reactive power flow. The physical significance of leading and lagging, it represents reactive power flow direction. Capacitor will be leading. Capacitor current is leading with respect to voltage. Now, so that means what? You know, if you take up inductor and capacitor, you will be getting inductor current as lagging, capacitor current as leading. So inductor power component will be, inductive reactive power component will be downward. Capacitive reactive component will be, power component will be upward. So the power flows in the capacitor and inductor will be quite opposite. If inductor is consuming, capacitor is going to deliver. If capacitor is going to consume, inductor will deliver. That is how you need to understand. Reactive power flow, it is going to indicate about reactive power flow. Is it clear, Ananya? And everybody, is it clear so far? All right. So these are the conclusions I wanted to give. Please see here. These are the conclusions I am going to finish up. So please remember these things. For a series AC circuits, the total impedance will be frequency dependent. Why? Because j omega L and 1 by j omega C. So definitely it is going to depending upon frequency. And the impedance of any one element. The impedance of any one element. The impedance means R is equals to Z is equals to R plus j omega L. Out of the two elements, element 1 and element 2, any one element. So this is Capacitance or inductive reactance is going to be depending, not resistance, right? Okay, so one element impedance is, or one element ohmic value is depending on the frequency. The impedance of any one element can be greater than the total impedance also. How is it possible? It is possible like this. If I take up this one, 1 J2, and this will be minus J10. The impedance of one element can be greater than the total impedance. Okay. Total impedance, if you go ahead, you are going to get it as minus 1 minus J8. Okay. One element impedance is maybe, if you take up only inductance, it will be J2. One element impedance, obviously, it is like, simply what I can say is, in this manner. You please be careful here. This point is, if you connect only resistances R1 plus R2 plus R3, the total resistance will be greater than the greater value. Okay, greater than the greater value. If R3 is greater, then total resistance will be greater than the greater value. Okay, but here, as it is a frequency dependent, he is saying the impedance of any one element can be greater than the total impedance. Because of frequency dependent nature, this is going to be compensated. Okay, J2 and minus J10, but resultant is how much? Minus J8 only. So this minus J8 is greater than J2. Of course, the magnitude you are saying, if you are taking about magnitude, so that is the reason why he's saying the second point like this. Because of presence of inductance and capacitance, there is a chance of compensation. So because of that compensation, the resultant value will be greater than the one element value. The resultant value will be greater than the other element value. Okay, did you understand? Third point, the inductive and capacitive reactants are always in direct opposition. Yes, one is leading, another one is lagging. Looks like that. Depending upon the frequency applied, the same circuit can be either predominantly inductive, can be predominantly capacitive. If XL is greater than XC, then it will be inductive. If XC is greater than XL, it will be capacitive. Okay. Did you understand this point? So these are the conclusions I just wanted to give. At lower frequency, the capacitive element will be usually have the most impact. Why? This is 1 by j omega c. So 1 by j omega c, if you have omega equal to 0, so it will be infinite. Impact on the total impedance is going to be, if you are going to connect in series, how it is going to look like? Inductor is going to be short circuit, capacitor is going to be open circuit. So capacitor is going to have a huge impact on the total impedance. It will lead to infinite simply. While at high frequencies, inductive nature is going to be much dominant. Why? J omega L. J omega L, infinite. At high frequency, infinite frequency, you are going to get infinite ohms. So this will look like an open circuit now. At low frequency, capacitance is much dominant. At high frequency, inductance is much dominant. Okay. In the second case, how the circuit will be? Resistance and inductor is going to be open circuit. Capacitor is going to be short circuit. Capacitor is going to be short circuit and inductor is going to be open circuit. So that is what it means. The magnitude of voltage across any one element can be greater than the applied voltage. The magnitude of voltage across any one element, maybe inductor voltage, capacitor voltage. Inductor voltage is going to be, can be greater than applied voltage. How it is possible? It is possible because of resonance. Q times the supply, VC, Q times the supply voltage you are going to get. Voltage magnification is possible due to resonance. Okay, if you solve, you'll come to know VL is equals to I JXL into I. What is this JXL? J omega L, na? This is J omega L. J omega L into I. What is I during resonance? During resonance it will be V by R. So J omega L by R into V. J omega L is written, omega L by R is written as Q. So JQ times V. Inductor voltage is Q times the supply voltage. Voltage magnification is happening. Next point, voltage magnitude. The magnitude of voltage across element compared to the other elements of the circuit is directly related to the magnitude of its impedance. Yes. Higher the impedance, higher the magnitude voltage. Lower the impedance, lower the magnitude voltage. Whatever the, that is what in the last session also we have discussed. Large resistance will capture large part of the voltage, large voltage of the supply. Small resistance will capture small voltage of the supply, out of the supply voltage. If 100 volts is there, if I have a large resistance, out of 100 volts, maybe 90 volts is going to be captured by this large resistance. If another resistance is smaller, it is going to capture only 10 volts. Smaller the magnitude, smaller the voltage, larger the magnitude, larger the voltage. Because current is same. Now, 8th point. The voltage across coil or capacitor are always in direct opposition. That is what now? Opposite. We have drawn, if you take up current as reference, voltage across inductor will be here leading, voltage across capacitor will be lagging. So directly opposite. The current always in phase with the voltage across a resistive element, lags the voltage across the inductive elements by 90 degrees, leads the voltage across the capacitive elements by 90 degrees. So this is what we have seen so far. Larger the resistive element of the circuit compared to the net reactive impedance. The larger the resistive element of the circuit compared to the net reactive impedance, the close is the power factor to unity. What does it mean? I have a Z R plus J plus or minus Jx. If I have a resistance of 100 and reactance of just 1 ohm, let it be 100 plus J1 minus J1. So how I am going to write real and imaginary. So I can write here it as 100 real term is very large, imaginary term is very small, imaginary term just this much. If it is inductive reactance, I can take up this is the resultant. Now see, the angle is very small. If angle is very small, the power factor of smaller angle, it will be very near to unity. You see, negative capacitance, that is capacitive reactance also this much. If you take up this much, the resultant impedance is going to be this much. Here also the angle is very small. Cos of very small angle will be the magnitude will be very near to unity. So these 10 points you need to remember. You need to understand. So on these 10 points only we just discussed so far. On these 10 points only we discussed so far. Okay. Yeah, Ananya, resonance means current and voltage will be in phase. I did not look into your comment. I'm so sorry. Since long time I was in hide mode. Okay. So so far we have discussed about these 10 points only. How the current leads the voltage, or in the inductor how it is lagging, in the capacitor how it is. We have seen the graphs also, we have seen impedance diagrams also. Alright. So these are some questions on AC circuits. I have got some questions also. Please look into them. So take up this as homework. He is asking to express the impedance in the figure in both polar and rectangular. Polar is R at an angle theta, rectangular is X plus Iy. In this format, you have a omega also, so you can represent. Here also the same thing. Take up this as homework. If R is there, no theta is 0, right? The angle between voltage and current is 0. You can take up the frequency. Be careful, here it is frequency, here it is omega. So you have to write it as 2 pi f. Be careful. Now here, simple thing, question looks like lengthy but answer is so. Find the type of impedance in ohms of the series circuit elements that must be in the closed container. This is the closed container. We have a series element. I have element 1 and I have element 2. So like this. For the indicated voltage and current to exist at the input terminals, find the simplest series circuit that will satisfy the indicated conditions. Here is the voltage and here is the current. If you take up the voltage as a reference, E 120 at an angle 0 and current is 60 at an angle 70. So plus 70. So here is imaginary. Plus 70 means how? Plus 70 means near here. Current magnitude is 60 amperes. Now from the voltage the current is leading. Anti-clockwise, if you go positive, it will be leading. Current leads voltage or E by how much angle? 70 degrees. Now can you tell me what is that element? What are these elements? Definitely one should be resistance. Another should be, what is the element, mine? What is the element? Can you tell me? So it is going to be capacitor or not? Okay. All right. So in that way you can do this. Very good, Yogananda. Very good. So let's move on. So you can find this as, you can take up this homework. Here also this one you can take up homework. We will take up this one anyhow tomorrow. Try this one also. Simple questions I have given. Try this one also. All right. Chalo. Thank you. Thank you so much. Have a nice day. Bye bye. See you. Okay. So take up this. I think it is very slow. It is going very slow. If you have any doubts, you can post your doubts here. If you have any doubts, you can post your doubts here. Okay. I'm going to project the, I'm going to send the PDF also. So look into the, download the PDF. If you have any doubt, you can take up a snapshot and post. Thank you. Thank you so much. Have a nice day. Bye bye. See you. Anybody has doubt, please tell me if you have anybody doubt. Right. Tomorrow we'll see again. Tomorrow again at 12:30 p.m. Tomorrow we will take up parallel DC circuits. Then parallel AC circuits. Then I'll combine. Okay. All right. Thank you. Thank you so much. Have a nice day. Bye bye. See you. Yesterday it was series DC circuits. Yogananda, series DC circuits.